So now we're going to talk about buffers. Buffers allow a solution to kind of maintain its pH, even though you can be adding strong acid or strong base in there. Normally that would cause a rapid shift in the pH, just like we got with the titration reactions. But here we're going to see minimal shifts. And what we do for that is we allow similar salts in there, which help shift the reaction. So when you have a buffer solution, the pH is maintained, as we just mentioned. Here you can see when we have just water, or even water with an indicator in it, we get these rapid shifts. And so this would look to me to be a litmus indicator, where we have red in the presence of an acid and blue in the presence of the base. And a mix of the red and blue giving us a purple here at our neutral pHs. Buffers resist change in pH because they have the ability to absorb some of the hydrogen and hydroxide. Getting into our connections to the body, this is incredibly important when you're eating acidic foods, to make sure that that pH is balanced, because your body needs a particular pH, and changes in pH can be an indication of something very wrong in the body. And so your bloodstream has buffers in it, it tends to maintain a pH of about 7.4. And so that buffer allows you to eat things that are acidic in nature and yet not throw off the pH of the body. So what you have in a buffer is a weak acid and the salt, the ion here of the conjugate base. And then it has equal concentrations of these two. That is, the molarities of each of them are the same. So for example, if we have acetic acid, which has the acetate ion, then we might use something like sodium acetate, which also has the acetate ion and is soluble, so that we get that acetate ion in solution. And so the presence of that acetate ion then allows us to shift this reaction. And so because that acetate ion is there, we're increasing the concentration of this. And if we're adding stuff on the product side, recall, that's going to favor the reverse reaction, and it's going to produce the acid here over on this side. And it's going to allow this thing to have some reserves to dissociate back in to replace this, which is what's going to help maintain the pH that comes from the dissolved hydronium ion here. And so, for example, if we have the acetate ion here, the weak acid and its conjugate base in solution over here, then after the addition of base, what happens is, of course, the base is going to neutralize some of the acid, but in the process, the conjugate base is going to increase in concentration, which is going to allow that shift in the backwards direction. And so then, because that conjugate base is there, it will react with the acid that has been produced, and it will neutralize it. You'll notice this here is the reverse reaction just listed out, and so we will recreate the acetic acid, and this helps maintain the pH. And so you can see the restorative factor here. And so the reason the buffer works is because we have both a weak acid and a base here. And so each piece here has the ability to resist an acid or a base. The weak acid here is going to successfully neutralize a base that's been added, which is why you see the amount of acid over here go down. Whereas if we add an acid to the solution, then the base here, the conjugate base, is able to handle that. And that's why you see the conjugate base go down here. And so here we have equal concentrations of the acetic acid and the conjugate base of the acetic acid at the start, and then adding either one is going to, adding an acid or adding a base is going to affect the concentrations of each of those, but we have both an acid and a base present, and the presence of the acid and base allows them to react with the addition of an acid or base and neutralize them. So then here, the question is, which of these is a buffer solution? This one here is not a buffer solution because we have a strong acid. This does not work with strong acids because you don't get that reversible reaction. Strong acids completely dissociate. So even though we have a common ion here, it's not a buffer because we have a strong acid. Here we have a weak acid, and when we pop off one hydrogen from there, its conjugate base is going to be an HCO3, and we can see that HCO3 here. So then yes, this is a buffer. Here we have no common ions. This is a phosphate ion, and so even though this is a weak acid, we would have to have sodium phosphate or some other phosphate compound here. Actually, we'd have to have dihydrogen phosphate. We'd have to have an H2PO4 minus salt to have a buffer, and so then there's just no common ion here. This one here, we have acetic acid, again a weak acid, and within the acetic acid we see the acetate ion. In the example a moment ago, it was sodium acetate, here is potassium acetate, but what matters is not the cation there, but the conjugate base, the common ion here for that. So this is a buffer. I said but did not mark that that was not a buffer. So we have not, yes, not, yes. And lastly, this here is just a summary of the whole thing that we've had here so far. And so we started out by defining what acids and bases were, and then we got into the differences between strong acids and weak acids, strong bases, weak bases, the difference between strongs and weaks. From the weaks, we looked at the Bronsted-Lowry principle and looked at reversible reactions that have equilibriums that we can shift. We then got into talking about how water itself is amphoteric and can behave as both an acid or a base, which gives us the water constant, and we can use the water constant to calculate pH, or pH to calculate the hydronium ion concentration, which is the reverse calculation right there. And then we talked about the types of acid-base reactions, but this kind of leaves off the other reactions, the carbonate and the bicarbonate and the metal reactions that we talked about, but focuses specifically on the neutralizations, which form salt and water, and we can also do titrations to measure the unknowns there if we have that. And when we have a weak acid or a base and a conjugate, we can use create a buffer, which will help maintain and allow there to not be large shifts in pH. That's everything for this unit. Certainly, if you have any questions, don't hesitate to reach out to me.